In this video, our goal is to evaluate the following sum. So we have here the sum from 0 to infinity of the rational expression 1 over x squared plus 6x plus 8. Before we start, I suggest that you first try this one out on your own. So let's begin. So at first, what you might think is to start and begin expanding this one. That could lead you somewhere, or that could end up being a disaster. So take note here that actually the trick is to observe that we can use the following concept. So the key is to use partial fraction decomposition. The main idea here is that if we are given this expression, we can actually break it into, say, a over some linear factor here plus b over some linear factor here. And from there, that is what we will analyze instead of this. So to apply partial fraction decomposition here, the very first step is to factor out the denominator into its linear factors, or irreducible factors to be more specific. So in this case, we have x squared plus 6x plus 8. Notice that this is a quadratic expression, so it can easily be checked that this factors into the two linear factors, x plus 2, and what's the other one? X plus 4. Once we have that, the next step is to begin applying the partial fraction decomposition. So the key in applying partial fraction decomposition is to first consider some constants, let's say in this case, a and b. So if we consider these constants, then take note that we can rewrite the given rational expression. So this one here, so let me write it out here. So take note that we can write this by the partial fraction decomposition in terms of the denominator of its linear factors. So we'll have here x plus 2 plus x plus 4, wherein the numerator here are given by the constants a and b. Okay. Take note that this isn't actually the simplest form out here. If ever this one is not irreducible, then we'll have a different form. If ever this one factors into a perfect square, we'll also have a different form. But for this specific case, that our denominator, quadratic denominator, factors into distinct linear factors, this is what we'll have here. So let me first adjust this one. Okay, good. Now from here, take note that we can multiply x squared plus 6x plus 8 both sides just to eliminate the denominators. So for the left side, we will have 1. For the right side, take note that x squared plus 6x plus 8 is equal to x plus 2 times x plus 4. So if we multiply this both sides, for this first one, the x plus 2's here will cancel out and we'll just be left with a times x plus 4. Applying a similar process to this one, it can be checked that we'll have here b times x plus 2. Now here, there are various ways in determining a and b. First, one can expand this one and then compare the coefficients to match this left side. At least for me, an easier alternative is to just use test values. So in this case, a particular test value that we can use is x equal to negative 2. Why is that? Well, at x equal to negative 2, this thing here will vanish. So we'll just be dealing with a single missing constant, which is a. So at x equal to negative 2, take note that we'll have here 1 equal to a times the constant. Negative 2 plus 4 is 2. And then this is just plus 0. And then observe that if we simplify this, we just disregard this, divide 2 both sides, then we will obtain that a must be the constant given by 1/2. Applying a similar process to obtain b, you can guess what will be our test value. It would now be negative 4, since negative 4 would make this thing here vanish and we'll just be left with a single constant to find. So doing that one, so we'll have here 1 equal to 0 plus, let's see, b times negative 4 plus 2 is going to be negative 2. So again, similar analysis, dividing negative 2 both sides will yield as b equal to negative 1/2. So these are our missing constants, and so by partial fraction decomposition, so what we'll have here is the following. But this time, a and b would now be replaced by 1/2 here, and then here negative 1/2. And then upon further simplification of this, it can be written as 1/2 times 1 over x plus 2 minus 1 over x plus 4. And this is actually the form that would give us what we want. Good. So now that we have this form, what we next do is to go back here and replace this one. But before we can do that, so we first name this as, let's say, S to denote sum. Before we can replace this with the following, take note that it's still kind of hard to analyze this since we are dealing with infinitely many terms. So with that fact, the natural thing to do here in dealing with these problems is to first truncate or cut this series into a certain number. So that means, let's see the alignment. So let me move this a little here. I'm trying to save space since I think this will be kind of plenty. So the next thing to do here is to consider what we call the partial sum, S sub n, for some constant n. So that means basically what we'll have here is the sum S sub n equal to the sum x equal to 0 up until n of the same given. So that is 1 over x squared plus 6x plus 8. Got that one? Basically, it's the same thing as this one, but we'll only be considering 0 up to capital N. Now here, we replace this with what we obtained earlier. We can write this as, again, the sum from 0 to infinity, but we have a constant here. Since this is just addition, we can factor out the constant 1/2 outside, and what will be left inside is difference of 1 over x plus 2 as well as the function or the expression 1 over x plus 4. Okay, and then expanding this one, so this one will be quite lengthy, so let me write it first. Whew, there you go. So this is the expanded version of the sum. From here, initially, notice that the 1 over 4s here would cancel out. Moreover, even though it's not written here, the next term here will be 1 over 5 minus 1 over 7. So the 1 over 5s here would also cancel out. And the same applies for 1 over 6. So for the initial terms, what's only left is 1/2 and 1/3 out here. For the last terms here, notice that n plus 2 here cancels out with this. But then again, similar analysis, the previous term here is given by 1 over n minus 1. Let me write that one down. 1 over n minus 1 plus 1 over n plus 1. So the n plus 1s here would cancel out. And the same applies to 1 over n. So for the final terms, the only terms that aren't cancelled out are n plus 3 and n plus 4. Which means that this huge sum here just actually simplifies to the following. So that we're 1/2 times what's left with us is 1/2 plus 1/3 minus 1 over n plus 3 minus 1 over n plus 4. Ooh, pretty nice. So this is the partial sum Sn of the original sum here. Once we have this, the final step is actually pretty simple. We just let n go to infinity. Once we let n go to infinity, this Sn here would now represent our original sum since we'll have infinity now here. Take note that as capital N approaches infinity, let me fix this one first. It's bugging me. So let's write this better. Okay, and this one, I guess. There you go. What happens is that as n approaches infinity, these two things here would go to 0. So let me write that one down. So what happens is that as n approaches infinity, the expressions 1 over n plus 3 as well as 1 over n plus 4 goes to 0. Then this means that S here, our main goal sum, S, which is just represented by this, but this time we replace n with infinity, would just be represented by the removal of this, and what's left is this. What I mean by that is we'll be left with here with 1/2 times 1/2 plus 1 over 3. Simplifying, you can check that this just simplifies to 5 over 12. And this is the answer that we are looking for in this problem. It's a pretty nice problem. It's kind of tricky at first because we have an infinite sum, and expanding it initially would be problematic. But all you need to do is to know partial fraction decomposition, apply it to be able to rewrite this in terms of this, apply this process, which we actually call telescoping sums, to obtain this simplified form, and then from there just use this fact here so that we'll obtain 5 over 12. That is the answer for this problem. Good, so I hope you enjoyed that one. If you have alternative solutions, feel free to comment it down below. And besides that, have a great day.